Hello everyone. This particular research work we are mentioning as a versatile approach to polygonal object avoidance in indoor environments with a hardware schemes using an FPGA-based multi-robot. We are the authors of this paper are want to provide the experimental results to the uh, journal. Coming to the ideation was we are having of a totally three particular things. One is a polygonal type obstacle identification. Second one is the obstacle avoidance by multi-robot and formation and deformation by multi-robots. It comes to the scenario which we have created of a scenario. This was the at node E, the scenario. At this particular point, the multi-robots are in a formation model. Once they are found out there is an obstacle and identification was confined from themselves. Yes, now there's a left robot. Later was a informed through the Wi-Fi connectivity. It was the left side of the follower robot. Similarly, it was the right side also. Then they performs their operations and move forward. Right. And coming to the point of a hardware schemes which we have mentioned over there, we are having of a inter-model and intra-model. Intra-model is a consisting of the partial reconfiguration is a very hardcore of the novelty. The partial reconfiguration having of it performs like a obstacle avoidance, identification, avoidance, and a behavioral control models. Based on the event condition, it acts and by this the resources are consumed very less. That was we can observe in the paper. Let comes to the results point of view. We are looking towards the result point. Yes, here the scenario versus the obstacles which the robots will explain. These are four robots which we mentioned. Both are the leader robots. There's a left robot. There's a right robot. This is a confined information that there is an obstacle towards the followers. So then they are performing of obstacle avoidance under the lens of the bug2 algorithm. In this scenario, both the robots are taking off the odometer distance from this particular point to this part, and they recorded of that information by using of a soft technique, and the same technique was restored in the FIFO internally. Then it works of the performing of the job. Now, as a part of the obstacle avoidance, at this condition, the leaders will follow the boundaries of the obstacle, and they reach us towards this particular point. Now, if we observe there was a two follower robots are reached towards this particular one, based on the distance, already the leaders are left toward that part and followers are moving away. Right now, in this scenario, follower robots were searching anything is there and in that process. When you look into the leader conditions, both the leaders are appearing close and close. We also created the model internally while the time of the obstacle avoidance, the collision avoidance means nothing but we're calling as a dynamic obstacle. It should not collude with the other robots. That's the way we have mentioned about this scenario. In this scenario, this part we are calling as a node B point. If you look into a node B point of this particular node B point, we are having of a robot. Both the robots are reached towards this, and the followers comes following that. Now in this scenario, node B, yes, the passage and a free path was a very small space, though, so formation mechanism cannot be performed here. So there is a formation in place of lock. It is going to form as a formation, means a linear formation. One after the other robots will pass through this particular space that we are mentioned at a node B. That was a scenario now present. The experiment was conducted by the leader robots. Right, in this scenario, right, the left leader was moving towards the obstacle. Once the leader robot reaches towards the obstacle, the other robot, which was the right side leader robot, was moving forward towards the obstacle. Right, means after a linear formation. Here, the challenge of the left robot is it is a calculated of the odometer technique, and we're using of the perpendicular action with a certain angles. It is supplied towards the cordic and calculated that what was this angle. Based on the sensory information and acoustic information, it can computate that values and confine that was a type of obstacle is a triangular type of obstacle, because we mentioned that there is a different types of obstacles and in a polygonal shape, and also their orientations were different orientations. Now coming towards the here, the the right hand side robot was moving forward towards the next extension, moving forward, and left robot now it is waiting, because it understood that it was exactly one of the corner it is reached in the triangular model. So the next it performs of the perpendicular based of the obstacle avoidance mechanism. Means, so how we know there's a mean by whatever the travel of the distance, the odometer technique it is going to perform and comes towards this particular distance evaluation by the height of by the Euclidean distance and the hypothesis method. It reaches towards the exactly the point of center point, means close to the center point of the obstacle. Means now it takes a decision of the left robot towards the again into the formation, because there was a free space to it. So the left robot was reaching towards the exactly the point of the until it waits for the next reaching of the other robots. Now at the right side robot, yes, it is waiting until the left robot leader is moving towards its position. Then the right robot is also taking off its decision and calculating of that. It's a very simple one. It's like a wall following approach, and then it moves over, and not a big computation things performed here, but it was also the parallel method which we have developed over here. All these formation, deformation, and obstacle identification, avoidance mechanisms are performed by the switching of the event to event by using of a partial econification technique, which we are users in the FPGA computation. All the 4 robots are having of FPGAs internally. The ultrasonic sensors we are going to use for observing of obstacles and calculating using of a sensory fusion exactly. The very hardcore of the thing is the CORDIC algorithm was we used for the from the Xilinx IP core as an academic support, so that we are able to deploy that a CORDIC IP core for a computing of the angles of the orientations which we are having in a robot. Yes, these are the obstacles we calculated and we supplied of this particular one. Now, if we observe that, yes, there was the follower is also the left side was completed and right side robot was searching for its computations and moving forward, and positioning is exactly next. It's a verifying way or type of the thing is right now the robots are reaching here and towards the exactly the avoidance their leaders and follower positioning values. Yes, now there's a written a formation mechanism from the obstacle avoidance to total formation to deformation method. Thank you.